Behind the Origin, Beyond the Infinity. Chapter 2. Investing in Research Megaprojects and Infrastructure. The natural sciences are built on experimental data and observations. General and special relativity, quantum theory, and the standard model of particle physics were created to explain observational and experimental data. Sometimes, mathematical models and hypotheses are created before experimental data is obtained, and they predict phenomena that must be tested experimentally to confirm the validity of the theories, refine them, or reject them. To obtain new data, complex and expensive instruments are being built. Particle accelerators, ground-based and space-based observatories, research satellites, and interplanetary missions. Infrastructure megaprojects can accelerate scientific progress by discovering new effects and phenomena or testing theoretical hypotheses. The most ambitious projects cost billions of dollars and take many years to develop. Here are some examples. The total cost of the Large Hadron Collider was over $5 billion, including design, construction, and maintenance costs. After approval, the project was implemented for 13 years, from 1995 to 2008. The Hubble Space Telescope was launched into space on April 24, 1990, after more than 20 years of development and a cost of $2.5 billion. Including subsequent maintenance and repairs, the project cost exceeded $10 billion. The more advanced James Webb Space Telescope was launched into orbit on December 25, 2021. Its construction and launch cost over $10 billion, and like its predecessor, Hubble, it was developed over 20 years. Regarding ground-based telescopes, the Extremely Large Telescope is currently under construction in the Atacama Desert in Chile. It will be the world's largest optical observatory. Scheduled for completion in 2029, its development and construction will therefore take approximately 20 years. Costs are estimated at approximately $1.5 billion. An example of the cost of interplanetary missions is the Curiosity rover, whose construction and launch cost approximately $2.5 billion. Curiosity launched on November 26, 2011, and arrived on Mars on August 6, 2012, where it began its exploration of Gale Crater. The project's development took nearly 10 years. Another interplanetary mission, Cassini-Huygens, cost approximately $4 billion and was developed over a period of approximately 10 years. The spacecraft was launched on October 15, 1997, to explore the planet Saturn, its moons, and rings. On January 14, 2005, the Huygens probe successfully landed on Saturn's moon Titan, the first human-made object in history. Cassini collected data in orbit around Saturn until its mission ended on September 15, 2017. These are examples of the costs and timelines of just a few megaprojects that have yielded or will yield crucial research data for humanity. Their cost, measured in billions of dollars, seems enormous to the average person. However, not all projects receive funding approval due to bureaucratic or financial difficulties, which delay their launches for years or even lead to their cancellation. But are these costs truly enormous when compared to the budgets of governments, organizations, companies, or even the capital of the richest persons? In 2025, there were at least 15 people in the world with a net worth of over $100 billion. The number of people with a net worth of over $10 billion is several hundred. The number of people with a net worth of over $1 billion is over 3,000. Many of them are developing businesses in computer science, energy, biotechnology, and medicine, and contributing to the progress of humanity. But they could also write their names in the history of fundamental science as philanthropists of the largest megaprojects in human history. The cost of global scientific projects may seem even smaller compared to the value, turnover, and profits of the largest companies. For example, the total market capitalization of the S&P 500 index in 2025 exceeded $50 trillion. The market capitalization of 9 American companies exceeded $1 trillion. According to data for 2024, The largest global companies paid out over $1.7 trillion to their shareholders. Among them, American companies paid over $600 billion in dividends, and European companies paid over $300 billion. But undoubtedly, the governments of countries with the largest economies have the greatest financial resources. Global GDP in 2025 exceeded $100 trillion. The USA GDP in 2025 approached $30 trillion, and China's approached $20 trillion in nominal terms. The USA, China, Russia, India, and European countries spend tens and hundreds of billions of dollars annually on fundamental research projects. For example, NASA's budget in 2025 was approximately $25 billion. However, these expenditures represent a very small share of government budgets and GDP. To write your name into the history of science, you don't have to be an outstanding scientist with academic degrees who personally makes discoveries. Sometimes it is more useful to be a wealthy person, an entrepreneur, an investor, a top manager of a big company, an influential politician, or a public figure. It's essential to be someone who will dedicate significant personal or public financial resources to helping humanity reach new horizons of understanding the universe.